So welcome everyone to the Getting Started with PLAll's class. I'm Matt Harrison. So if you go to this link, this will take you to the GitHub project here for the course. And one thing I found out is that, so the link is Matt Harrison in GitHub, and then it's 2023-PyCon-PLAll's. If you hit period when you're in here, it will launch this thing called code spaces, and you can actually run this all from code spaces too if you want to. So I don't know if anyone needs help with that, but otherwise, if you download the if you clone the project, or you can download the notebook, either way will work, and then pip install PLAll's. You should be mostly good. You probably want to install, I believe, PLAll as well, if you want some Pandas capability. Okay, so I just want to maybe go around the class really quickly and understand our backgrounds here. So who here is working sort of in a data science-like capacity? Okay. You want? Uh-huh. Uh-huh. Okay. Okay. So we got a lot of data science-y people in here. Who here uses Pandas? Okay. So I imagine you're here because you're either looking for something different or you're just curious. I mean, I'd be interested in knowing like what your motivation is for being here. One thing to note is like we are kind of small because this was just put together Monday. The PyCon reached out to me and said, "Do you want to do a tutorial?" We have someone drop out. I'm like, "Sure." And they're like, "Okay, you're doing it," and that was like the end of it. So there's not been a lot of marketing or whatnot, but I guess that's fine for you all. What's the motivation for PLAll's? Anyone want to like share?
Before Pandas 2.0 came out, I really wanted to have something that was a lot more efficient when it came to speed, memory safety, also kind of endeavoring to learn Rust.
Okay.
So anything that kind of uses Rust is just interesting to me.
Okay.
I'm kind of surprised to see PLAll's at a Python conference.
Yeah, so the comment for those who didn't hear, speed, memory, and ancillary interest in Rust as well, okay?
I'm just curious, I use Pandas a lot, and
Okay.
there are certain methods that just don't work very quickly, and PLAll's is advertised as kind of the faster Pandas. So
Okay.
Okay.
So whether PLAll's is the end-all be-all to all of our Pandas woes sort of thing, okay? Anyone else?
Mostly just
Curious,
curious.
okay. Okay, so let me give my background, just so we're like on the same page as to like what's going on here. I mean, I wrote this book, Effective Pandas, and my job is corporate trainer. So I like to say that I sell snake oil and teach people to tell lies with data, but I spend a good deal of my time in front of larger groups than this, helping them level up in Python and learn things like Pandas and machine learning. And so I've been using Pandas almost since it came out in both professional capacity and then more recently in consulting and training capacity. But I use it often on my own data as well, in addition to like consulting and whatnot. So I feel relatively comfortable with Pandas, and PLAll's has been out for a while, and at the end of last year I'm like, okay, maybe I should like see what this buzz is about. And so this tutorial is a result of me basically taking, I would say, like a lot of content that I do in Pandas and sort of porting that to PLAll's and seeing like where the give and take is. So am I a PLAll's expert? No, not by any shot of the imagination. Am I a Rust expert? No, I'm not a Rust expert either. So what we're going to get here is, I'm biased, but a biased look at pullers, but hopefully we can sort of see like where the pros and cons are, and I think we can come to some preliminary suggestions on when it might make sense to use and explore a little bit more. Okay, so again, you can go to that URL, just download the notebook, throw it into Jupyter, and make sure that you've pip installed. You'll want to have installed pullers, and I believe PLAll as well. If you pip install both of those, you should be good. So I'm going to restart my kernel here, and I'm going to clear my output as well. Okay. And I think the schedule is we go till 10:30, then we have a break. I'm not quite sure how long the break is. Okay, I've heard anywhere from 10 to 30 minutes. So, okay, 10-minute break at that time. And then basically I've got this notebook here. It's got a bunch of examples, but it also has lab work in it as well. So what we'll do is I'll talk for a little bit. You can ask questions or whatnot. Nice thing about a notebook is you can try things out and play around in it. And then we do have some labs in there, so I'll give you some time to work on the labs, try out pullers on your own, and we'll just sort of rinse and repeat that for our time here. But yeah, like I said, I'm pretty flexible here, so if you have questions, feel free to just raise your hand, shout them out, and let's answer those. So I am using pullers 0.17.5, so I assume by the time this makes it out to like YouTube or whatever, this will be an outdated version of pullers, sort of only half kidding there. But like they release pullers pretty quickly. And so that is something to note, is that actually did a version of this talk at the end of last year, and I would say a good, not a lot, portions of it broke from doing it last year, right? So what's my point there? My point is that pullers is moving and evolving, and it's not, the API isn't stable per se, right? In fact, when I was doing when I gave this talk or gave this course a couple months ago, the creator of pullers actually reached out to me, and I went through it with him at that point in time. And so he kind of gave it a thumbs up or a semi-blessing and said, okay, yeah, we're good there. And it was kind of nice because he walked me through a lot of the mentality and the ideas of pullers. So if Richie's watching this, I'm sure he'll comment or correct things that I might say or misspeak at this point in time, because he seems to be pretty involved in that. So let's load some data here. So you can load this data, which is actually, let me reload this page here. Make sure that I have the latest here. Okay, so you can load this data if you've checked it out. Otherwise, if you haven't checked it out, run this one down here. This will fetch it from the internet. And so I'm just using, in pullers, there's a read CSV function, and that is making what we call a data frame here. And so this is the output of doing that. Anyone having issues doing that? So ideally, you're able to run what I'm doing and sort of follow along with me. So if you need help with that, let me know. This is the output. This is a data frame. So data frame, for those, everyone in here probably knows, but for those who are watching who might not know, is basically a representation of tabular data. And generally, when you're doing analytics, you want the columns to be of the same type. So this is a pullers data frame. At the top, you can see the shape of it. It's got 5,700 rows and 40 columns. This happens to be my tweet data for some portion of time. This is from Twitter. These are my tweets, and so this has analytic information about how I tweeted here. So what we're going to do is we're going to go through this and sort of assume that I was given this data set for maybe like a consulting gig, or I'm like doing a data analysis on this, and this is kind of my process of going through this data set and exploring it and cleaning it up. I mean, so a couple things to note if you are familiar with Pandas here. I mean, this looks kind of like a Pandas data frame. I mean, it says shape at the top, so the output is a little bit different. Pandas says shape at the bottom. It's got, it looks like column names, which should be familiar for people who are familiar with Pandas. And then below that, it's got types here. Just, I think everyone here is probably aware, but Python is a slow language. Python is not a fast language. And one of the things that makes a data frame library fast is leveraging some lower level tooling to optimize memory. And so Pandas, in the case of Pandas prior to 2.0, leveraged NumPy under the covers. As a Pandas 2, you get PyArrow support. Polars is leveraging Rust and a library called Arrow under the covers, a Rust implementation of this Arrow. Arrow is an in-memory representation to store analytic data or tabular data. And the benefit you get there versus storing this in pure Python is that basically Arrow is going to say, here is a column that represents the tweet ID, that's a 64-bit integer, so we've got 5,700 of these, so it's going to make a buffer that's like 5,700 times 64 bits, and all of that will be the tweet ID information in there. If you were doing that in Python, you would have a Python object for each of those IDs, and there'd be a couple dozen bytes of overhead for each of those. So in addition to saving memory, PyArrow also supports low-level operations that take advantage of things like multi-core or SIMD instructions. So when you do certain operations, they can be optimized and run very quickly. So a data frame library like this kind of gives you the best of both worlds in that you can write in a Python syntax but get C or Rust speeds by doing that. And so, yeah, we can scroll through this if we want to, but you can see that it's showing some amount of data here and some amount of columns. One thing to note here is, if you're familiar with Pandas, there is no index here. So Pandas will stick in an index. You can think of an index as a row ID for some purposes, even though indexes don't have to be unique. And there is no index in here. So that causes, I guess, changes or effects that if you're coming from Pandas, you just need to be aware that there isn't an index there. Also, Pandas does have the ability to do hierarchical columns and hierarchical multi-indexes, and Pandas uses the same data structure to represent an index and to represent columns, and Polars does not have hierarchical columns either, so it's just all flat. Okay, so in these cells here, I've just listed out what you get, just to sort of show you. So in the Polars package itself, you have a good deal of functions, of things that you can do. And then inside of the data frame, you've got a good deal of things that you can do. Now if I did this with a Pandas data frame, there's like 400 different things that you can do with a Pandas data frame here. With Polars, you're looking at quite a few less than that. So 176, I think Pandas is around like 430 or so attributes on a data frame. So a little bit less exposed there from that point of view. And then one thing to be aware of, there's also this notion of a column, and a column lets you do things that are called expressions. And so I'm just showing what is available on the expressions, and you can see that there's a good deal of things that you can do to a column. So like taking the standard deviation, the square root, sorting it, even things that you couldn't do, for example, like in Pandas. Pandas doesn't have like sign. It does have the ability to do some things that Pandas doesn't do. Okay. So let's explore our data frame. I mean, like if I just got this is kind of the process that I would do. And if I was in Pandas, I'd maybe explore the index. And again, there is no index in polars. So just be aware of that. Here are the columns. It's just going to give us a list of those columns. In Pandas, I'd probably do something like this. I'd probably like say take a sample of 20 rows and transpose that. And that kind of works too. And so why do I like to take a sample? What I find is that often the first n rows of the data are kind of either not complete or might have test data in them, or the schema hasn't been completely fleshed out. So by looking at the first amount of rows in the data, that's often not good enough to give me sufficient understanding of what's going on in the data. So just taking a sample of those rows is often better. And then transposing is just a little hack that I like to do, because often transposing, if you're not aware, if it flips the rows and the columns, transposing lets me often see a little bit more data than I would if I don't transpose it. So I'll often do that just to see a little bit more data. Sometimes I do transposing as for a part of a math operation, but a thing to be aware of is because we are column oriented here, when we transpose the data, you can see that all these columns basically went to strings, because in order to represent all of those strings was like the lowest common denominator that could represent everything. So you might lose some memory efficiency, and probably change might to probably will if you transpose your data if it has different types in columns. We can also inspect the shape here, so this is just a Python tuple saying the number of rows and the number of columns. Okay, so once I've got my data loaded up, I've kind of initially explored some of it. I might dive deep into a little bit more of it. And so one of the things I might want to look at is the types. And so there is D types, which again is similar to what you would see in Pandas. So we see like int64, UTF-8, float64, int64. So again, just to be pedantic here, these are not Python types. There is no UTF-8 type in Python. There's no int64 type in Python. There's no float64 type in Python. These are PyArrow types. And so this is for every column. This is the type that is represented, that PyArrow is using to hold that data. And we can ask it to give us the estimated size in bytes of this data. So this is saying that this is like 2.9 megabytes of data. Okay, so just let me comment on data size for a little bit. When I talk about Pandas, I like to say that Pandas is an in-memory tool or a small data tool, in that the Pandas, the library, not Pandas the API, but Pandas the library requires that you have your data in memory. Polars is similar in that generally you will have your data in memory, but it can also do some streaming. So Polars has a mechanism to do lazy evaluation, and then you can batch chunks of data through it if you want to. And so if you have data that's larger than memory, it is possible to use Polars to do that. I said Pandas the library, not Pandas the API, because there are other libraries that aim to implement the Pandas API. So one example is Modin. Modin strives to implement the complete Pandas API, as far as even going as far as to implement their bugs, but allowing you to scale that out across multiple machines. Dask is somewhat similar. And then, like, I'm an advisor for a company called Ponder, which is actually a company that's founded by the creator of Modin. The idea there is that they're taking the Pandas API to things like BigQuery and Snowflake. So you can take your Pandas code and run your same Pandas code on large data there. So the Pandas API is going to give you sort of like the breadth of like small data to big data. The PLAll's API is going to give you small data to sort of larger than memory, but not sort of scaling out to multiple machines, at least as right now is the state of that. And so because it is, I would say, you know, PLAll's does have some support for streaming, but you're generally going to want to be holding it in memory if you want to like materialize that or visualize that or stick that into like machine learning. So you generally will want a little bit of extra space to be able to do further operations on your data. So this data set is so small that it's not really a big deal, but you know, you might get other data sets that where you're kind of edging up to your memory limits, and so I'm going to show some techniques for lowering the amount of memory requirements if memory is one of the main pushes for using something like PLAll's. I will note that a lot of it, like I said, a lot of this applies to Pandas as well. And so you'll see you can do similar things for Pandas. So here I'm doing the describe method. This is actually the same as in Pandas. And I like to do this when I get a new data set. So what does this give me? It gives me summary statistics for my data here. And this is pretty similar to what we see in Pandas. We have count, we have null count. So in Pandas, count is the number of non-missing rows. That has a different definition in PLAll's. We see the mean, the standard deviation, the minimum, the maximum, the median, which is the 50th quartile, and the 25th and 75th percentile. So this is kind of nice just to go through our data and kind of understand what's going on with it. Some of the things that I like to do when I have something like this is to like go through like the maximum value and the minimum value and try and understand, you know, is the data type that it is using the appropriate one. And by default, PLAll's is going to use 64-bit floats and integers, which may or may not be appropriate. You can also ask for quantiles in there, like 25th percent quantile. Actually, don't know if you can do this. Let's just try it. Let's say like 25th and 70th. Okay, so Pandas would support something like that, right, where you'd get both of those. PLAll's does not. It just supports the one. And so if you look at this, again, there's no index over here sort of saying like this is the description of this. This is just the result of taking the 25th percentile of all of those rows. Okay, so having said that, what I did up here is kind of a no-no. I said like on the data frame, calculate the quantile. Generally what we want to do is we want to do these things called expressions instead of working directly on the data. And what are these expressions? The basic idea here is that you can think of PLAll's as a boundary. We've got our pi arrow, or not our pi arrow, our arrow data, and we got a Rust layer on top of that, and then we got a Python layer on top of that, which is the API that we're going through. And if we can keep things sort of in that Rust layer and below, we have some speed and performance benefits that we get from that. If we are crossing that boundary up to the Python one, that can give us some flexibility, but it will also slow things down because then we have to go from Rust to Python and back. So the expressions are a way, if we can express things in form of using these expressions, it keeps us in that Rust layer, so to speak. Okay, so it starts to look something like this, which is, again, completely different from what you would get in Pandas. Say df select and then PLAll. So we're saying I want to run this select, which is going to select columns, and then this is an expression that represents all of the columns. So that all is from the Polars namespace there. You can also do things like saying PLAll.call and then give it a name, or you can say star to select all of the columns, but we'll do that saying all there. We can also do something like this where we say PLAll, and then we can say PLFloat64. So this would give us all of the columns that are float64 columns. So this is similar to like a select D types in Pandas, this functionality here. You can also use exclude to exclude things, and this can also support regular expressions if you want to name things as regular expressions. So here I'm going to select the impressions column 2 times and give me a data frame with that. And when I do that, I get this error, a duplicate error, and it says that the column with name impressions has more than one occurrence. So this is another thing that's a little bit different. If you're used to Pandas, Pandas would allow you to do this, where you'd have the same column multiple times. Polars is just saying you can't have columns that have the same name. So if we wanted to do something like that, we could do something like this, where we say, let's take out impressions, the impressions column, but let's also take out the impressions column again, but it has this expression suffix _2, and so what that is going to do is it's going to change the name of the column and just stick the _2 there. And Polars is fine if we want to do that. Okay, so what I'm going to do here is I'm going to say, let's try and get, we saw that I couldn't do like the 25th percentile and the 75th percentile in one call to quantile. Let's see if we can do this another way. So I'm going to build up this little operation here. I'm going to say df.select, and I'm going to say, let's select all of these and do the 25th percentile, and then let's select all of these and do the 50th percentile and give that a suffix of Q5. And we can see that if we scroll over here, you can see that these have the suffix of Q5 over here. So this looks like that kind of worked. It gave us those. Now, if you were to do that in Pandas, you'd probably want it like vertically stacked instead of horizontally stacked like that. So I'll kind of show you how you might do something like that. So I'm going to say here, let's take the 0th percentile here, and then let's make a column. And so to make a column, you say this with columns. And here I'm going to say I want a lit, which is a literal column, or a literal value. And the value that will be put in this is Q0. So I'm going to put the string Q0 in there, and then I'm going to say alias. Alias is going to rename the column. So if we do this, we'll see that there should be a column called describe here at the end, and it has a value of Q0. So again, this syntax is completely different from Pandas, right? If I were to do this, I would use like an assign to do this. There isn't an assign here. This is how you create columns using expressions in Polars. Okay, so here what I'm going to do is I'm going to say, let's do the literal here as described, and then we'll do the quantile there, and we'll just stick that at the front. You can see that now is at the front. Okay, so this is kind of an attempt to emulate Pandas describe functionality. When I initially, so again, like I said, when I initially did this, I talked with the creator of Polars to go through this. When I initially did this, Polars had describe, but it didn't have all of the features of Pandas in describe. I think because of our discussions or maybe whatever, they since put those in. But when I initially did this, it didn't have like the 25th and 75th percentile there. So this is an attempt to stick those in there. So what are we doing here? This is a little bit more involved. I'm saying we're going to concatenate in vertical, so we're going to stack these things on top of each other. And what am I going to concatenate? I'm going to concatenate everything from this list comprehension. So this is a list comprehension from there to there. I'm putting the star in front of it to unpack the values of that. So what are the values of that? That is saying we're going to take the df with the quantile 0, and we're going to say with these columns, which is each of these values here. So we're going to say Q0, and then we're going to select all of these columns and do the Q0, and that will be one entry in that, and then we'll do another one with Q.25, another one with Q.5, 0.75, and 1. And so if we do that, we get something that looks like this. Okay, and so we're taking, these are all of the ones that I created here, and then these are the other ones that came from there, and we're doing a vertical stacking of those. Okay, so that's, you know, maybe a little bit more complicated, and maybe more of a challenge. I mean, we are combining list comprehensions with this unpacking here to do that. But if you want to vertically stack things, it's a little bit harder to do because we have to do things like stick in a new literal as well so that we know what the rows represent. So I'd say that's sort of like a give and take. Like, we don't have the index. The index in Pandas would sort of represent that, and so we're having to kind of play games making a literal to label what the rows are. Okay, so what am I doing here? Here I'm saying let's select the time and the impressions, and we'll do these quantiles, 0, 25, and 1 for each of those. And then we'll transpose that. And so this is what that looks like. If I don't transpose that, I get something like this. So this is those different columns. And that looks okay, right? Transposing that, if I transpose that, because it doesn't have the index, I do have to say, like, include header is true. And then I have to say columns as well to get those column names in there. Again, if you want to, you can just explore like what happens if I transpose that without that. It looks like that. So those are some other, I guess, hoops that you might have to jump through if you're, you know, used to Pandas index functionality here. Okay, so this functionality that I put, I mean, up here, it's kind of, I know that's not the world's greatest code. I mean, it's kind of unsatisfying. I'm going to make a function here, like put this into a function. And so let's try that with pipe. So I'm going to say let's pipe the PD describe function in here. And we can see that that does work as well. So this is a way where you can refactor your code. One of the things you want to be aware of is, like, Pandas or Pollars has the notion of being lazy here, and in this case, like, can I make this lazy? Some things are, I guess, lazy. You're able to make lazy, and some things you aren't able to make lazy. So what does laziness give you in Pollars? Laziness gives you the ability to construct operations, a chain of operations, and then Pollars can go through that, and it can optimize. It can do things like query optimization. So similar to like a SQL database, where a SQL database would do query optimization. Lazy in Pollars allows you to build up all the operations and then do them in an efficient manner. And so in this case, because we are using like describe, it's like, no, you can't really make describe lazy because when you're lazy, Polars wants to know all about the schema, and when you do something like a pivot, it makes it hard to know what the schema is, and so you can think of describe as a pivot. Okay, let's look at the integer types here. So here's everything that's in integers, and I've got things like the number of apps that were open, the number of installs, number of follows. Again, this is Twitter data, and a lot of these look like small numbers. I mean, the tweet ID is a large number, but a lot of these look like small numbers, but I'm using a 64-bit integer to represent them, right? And so I might do something like this, where I say, let's do this chain here, let's select the integer types, and then let's do a describe on those. Okay, and if I look at these, so for example, like the app opens, that maxes out at 0. App installs is all zeros. Follows goes up to 191. Media views goes to like 16,000, and media engagements goes to 16,000 as well. So this lets me consider, like, do I need to use 64-bit integers to represent this data, right? Probably not, right, for a 0. I mean, if everything's 0, for the purpose of like machine learning, I could just drop that column because there's no information in it, right? A column that has no variance doesn't have any information. Something like follows goes up to 191, so if I use like an unsigned 8-bit integer, I could probably represent that in follows, assuming that I never got more than like 255 follows. So let's look at like how we might cast these into a different type. So here's impressions, right? And it turns out that there is a cast on that. We can say take impressions and cast it to an int32. That looks like it works. However, if I'm doing this with square brackets, I'm accessing the column here with square brackets, I'm not using that expression syntax, and so I'm not being able to be lazy, and Polars isn't able to make optimizations with that. So I do want to use this expression style instead, which would I would do that like this. I'd say I want to select, so instead of square brackets, you're going to say select, and then I'm going to say, let's take the impressions column, and I'm going to cast that to an int32. Okay, if I want to stick that back into the data frame with an expression, I will do something like this. I'll say df with columns, and stick that back into the data frame, and here's impressions. You can see that now it says that it is a 32-bit integer. Let's try and see if we can get it down to an 8-bit integer. And unlike pandas, if you try and do this, pandas will happily proceed and give you overflow errors. PolarShare is a little bit more smart about that. It says if you do that, you're basically going to be lossy because you've got values that are outside of the range of that. So the max value of impressions is this right here. So I'm going to cast it to an int32 instead, and that looks like that works if I leave that as an int32. So if you're curious about what the size range of these are, I wish there was some way. I don't know that there's a way in Polars to get this. In pandas, generally we go through NumPy. So NumPy has this thing called IInfo to get integer info, and FInfo to get floating point info. So you can pass in the NumPy types there, which should have the same range as the arrow types. But you can see that like an unsigned 8-bit integer is from 0 to 255. Right. So here's just some code that's trying to say, okay, let's take our data frame, let's select the float columns and the integer columns, let's do a describe on that, and then let's select the columns where if we go through this describe, I want the max value to be less than 255. Okay, and if I do this, I get an error here, and it says that this less than is not supported for instances of string and integer. What I need to do instead is a little bit more involved. I need to say like, let's pull off, so this is giving me this describe thing, and the second to last position is the max, and I'm checking whether that is less than some value here. So this is some code that I could do to say what are the columns where the numeric values are less than 255, and these are those columns right here. And so then I could maybe take this and say like, okay, well let's look at like maybe an unsigned 16-bit integer, and that goes up to 65,000. So maybe let's see if there are columns that we can make unsigned 16-bit integers there. And so these are the ones that could be unsigned 16-bit, but if you look at these are the same as these ones up here that were less than 255. So you could do like some set operations there, but basically most of those could be unsigned 8s, but maybe for growth purposes, if we're going to say like we might want greater than 255, we'll leave those as unsigned 16-bit. Again, unsigned can't go negative, so it really, I don't think it makes sense to have negative retweets unless Elon's changed that recently. So we should be okay with those unsigned values there. So what am I doing here? I'm saying with columns, and then I'm just using a list comprehension to say, take all of these columns here and make a new column expression that casts those to 16-bit integers. Now, that's using a list comprehension. Generally, we want to stay with expressions rather than sticking in Python code in there. So again, that is one of those things you want to be aware of is when you're crossing sort of that Python boundary there. And if you've got like a list comprehension in the middle of your chain, that can make it so pullers has to cross the boundary between Rust and Python here. So instead of doing it that way, saying a list comprehension here, it turns out that we can just say, with PLAll, we can just pass in the list of columns that we want. And that's the expression way to do that. Okay, so what I've got here is just a benchmark here. I'm going to run this here. So what do I have in the first one? The first one I have a list comprehension. In the second one I have the expression. For the purposes of this, the micro benchmark that I'm running on my machine, the list comprehension is slightly slower. I will say, like, caveats with timing and benchmarking. My experience is if you are benchmarking, at least in Pandas world, you want to benchmark with the size of data that you're going to be using in production. It doesn't make much sense to benchmark something on 10 rows of data or 100 rows of data or a few thousand rows of data if you've got millions of rows of data that you're going to be working with in production, because oftentimes there might be different paths that you're going through there. So just be aware of this. In this case, like, both of these take like around 200 microseconds, which I can't really comprehend 200 microseconds. It's not like a huge deal for either of these. You know, but if you had a few gigs of data, this might take a little bit longer, such that, you know, doing it the idiomatic Polars way with expressions, especially when you start chaining that with other operations, is going to have an impact on what's going on there. Okay, this one here, I'm being lazy. So again, Polars does have the ability to be lazy, and basically what laziness means is, instead of being eager and materializing or evaluating all of these operations as we do them, what we do is we build up this chain, and then Polars can analyze that and make certain optimizations here. And in this case, because we're only doing one thing, we're just doing that with comments there. There's no benefit for laziness here. Okay, so let's see, do we have any integers that need to be larger than those 16-bit integers? So here I'm just sticking in that magic number there, and it says the only column that I find here is the describe column, which isn't actually a numeric column. That's just, I said select the describe column and this column. So there's no columns in this data set that are larger than unsigned 16-bit integers here. So I might have a chain that looks something like this, where I say, with these columns here, cast them as 8-bit unsigned integers, and cast these ones as 16-bit, and maybe impressions, we leave that as 32-bit, and we get something that looks like this. Okay, and it didn't complain here, so this conversion should be lossless in that, like, we haven't lost any data or we haven't had any integer overflows by doing that. Okay, so if we look through the data here, you see that there's a bunch of these promoted values here where we have a bunch of nulls. It turns out that, like, I haven't paid Twitter to promote anything, so those values are missing. So maybe I want to filter those out, because if I'm doing analysis or machine learning, I'm not really getting any bang for my buck from those columns because they're not doing anything. So one of the things that we can do is do select, and sadly it looked like a recent version of Jupyter broke this cell magic. I don't know if this works on yours or not. So I need to explore that. This seems to be a Jupyter issue. But if you look at the help for select, the documentation, I would say the documentation for pollers is pretty good. And so pull up that documentation. My general recommendation for people who are working with libraries like this is to stay in Jupyter if you can, or stay in your environment. And so if you can pull up that documentation directly here, that might be useful. So you can see that, you know, it describes what's going on, and there's examples of using that as well. So I think this is pretty good documentation. So what I'm going to try and do is I'm going to try, let's see, if you go up here, let's see, select, it says these are the columns to select, accepts an expression input, so you can pass in an expression. Strings are passed as column names. Other non-expressions are passed as literals. So this should say that you can pass in a regular expression as well. And it doesn't say that, but you can. So here I'm going to pass in a regular expression here. I'm going to say, does this column start with promoted? Okay, so here are all the columns that are promoted columns. So again, select is the poller's way of pulling out columns. And so here I'm going to say, let's do this. I'm going to say select all of the columns, but then we're going to exclude the promoted columns. And that looks like that works. There aren't any promoted columns there. We see that there are only 22 columns now instead of all of our columns. So we might want to drop all those columns here. Again, you can pull up the documentation for drop. Here I'm dropping off those promoted columns. That looks like that works as well. So another hint that I got from Richie is that if your code's probably going to be better if you avoid using drop. So rather than using drop. So his point was, when I was going over this with him, he's like, I don't care about the columns that I'm dropping. I care about the columns that I'm working with. So rather than saying drop these columns, you should be explicit and say use these columns. And I don't know if that helps with their optimizations inside. There might be some optimizations where it helps, because it should have like the scheme of what's going on here. But here I'm just saying, let's pull off these columns here. So now I know what the columns I have are. And then instead of doing the drop there, I'm going to come down here and say, let's select these columns. So being positive on what you're selecting rather than saying what you're refusing here. So now I've built up this chain here where I've said, okay, here's my raw data, right? And then I'm saying I want to cast all of these columns to uint 8s, and then I want to cast all of these to uint 16s, and I cast all this one to a uint 32, and then I want to select these columns right here. Let's just run that and make sure that that works. It looks like it does work. It's not complaining, so we should be good there. Another thing I like to do is rename my columns. At least in Pandas, that's super useful because I'm going to be like pulling off the columns directly by attribute access. That's how I prefer to do that, because in Jupyter I get better tab completion when I do that. However, it's not such a huge deal here in Pollars because you don't really use attribute access to pull off columns in Pollars. But let's say that I did want to, I could do something like this where I say, I'm going to rename these, and I want to take my current column names and rename those. In this case, I'm using a pipe here. Let's try and do that, and that looks like it works. So what's the benefit of doing a pipe here? Well, when you do a pipe, you get the current state of the data frame, and in this case, I have the current columns in there, so I can refer to the current state, not the original state that had all those extra columns. And what I'm doing here is I'm just saying, do a rename, and I'm going to replace any spaces with underscores in there. You see that like tweet permalink now has an underscore in there. Again, not a huge thing for Pollars per se. In Pandas, I do like that because it makes it easier to work with. However, I am using like a lambda here, which might slow down the laziness here. So, and this is using like a dictionary comprehension. So if you want to get rid of like the dictionary comprehension, we can do something like this where we say PLAll, and because this is an expression, this all is going to refer to the current state of the data frame in our chain, not the original data frame. And then I'm going to say just map this alias here, which is a function, to clean all of those up. So this would be a more idiomatic Pollars way of doing that. Now I did stick a lazy in here. That instead of doing anything actually just gives us the plan. So if I comment out the lazy, you can see that this gives us that result here. So this would be like an example of what I might do if I was given a data set. Going through those columns, cleaning them up, and finding which ones I might need or not need. Okay, so we're at our first exercise here. This is for you. So your task is to select just the impressions and engagement columns, and then select all the columns except impressions and engagements without using drop. And then use rename to rename the impression column to imp and engagement to ENG. So I'll just let you work on that for a little bit. If you have questions or need help, let me know. Give you the chance to practice your Pollars. So there's a question. The question is like, what's the best way for like a comment and a question? One of the comments is like selecting, being positive about the columns you want is kind of maybe more work or annoying. So a couple things on that. I want to focus on writing code that's easy to read, not necessarily easy to write. And so those might be at odds with each other. But I think that being positive about what columns you have is slightly easier to read because you're making an emphasis on the columns you want. Now, there are cases where, like in machine learning, if you're making a pipeline and you're dropping columns, if that pipeline changes such that you're adding new columns to it, you'll break your pipeline. But if you're being positive about that, you're going to prevent that. And then the comment on that is, what's the best way to do that? Well, I'm kind of showing you my process. So a lot of times, like when people will see a chain, like I write a lot of Pandas code and I do chaining in Pandas code, and people are like, oh, that's a horrible chain or whatever. And what they don't see is that like I built that up, right? I didn't start off with like this huge chain. I sort of built it up sort of like what I'm doing here in this class. And so will I use drop? I mean, yeah, it might make sense for me to use drop and then find the columns and take the columns from that and then update my chain without the drop. So that's what I would do. So I'm not saying like don't ever use drop, but I would use that in cases where it makes sense or helps me to write my code that way. Okay, should we look at the solutions here, or some solutions? Okay, and I'm happy to, if you have yours, if you want to, ask about them, feel free to do that. Okay, so we have our DF here. So the first one here, select just the impressions columns. So I'm going to say DF, and then I would say, and I'm going to put it in parentheses here so I can so parentheses, in case you don't know, do you have to put parentheses around your chains? No. The nice thing about that is when you're inside a parenthetical in Python, you kind of don't have to worry about white space rules. And I generally like to put each step on its own line so it reads like a recipe. So that's why I like to do that. So I'm going to say select PL, and then I can say, I should be able to say just impressions here as a list, and engagements, if I spell it correctly with, so I'm going to spell it incorrectly, just, so I got a column not found error, and then one thing is I think is a little bit more of a challenge with pollers than maybe pandas is like, it does have like error originated just after this operation here, but the exception here is this column not found error. So you just have to make sure that you're reading this correctly. It's not like at the very end it's slightly up, but I have a typo there. So let's see if I can fix that. And that looks like that now works. Okay, select all the columns except impressions and engagements without using drop. Okay, so how would I do that? I should be able to do something like this where I say select, and then I should say like PLAll. Okay, so that's all the columns. And then I should be able to say like exclude. And let's say exclude impressions and exclude engagements. Okay, and then rename. So I'm going to rename these. So I'm going to say select those, and then let's do a rename. And we could pull up the documentation for rename, but I can pass in a mapping there. So I should be able to say, let's take impressions and rename that to imp. And let's take engagements. And rename that to ENG. Okay, what questions do you have?
Can you pass a function as the value to the rename mapping?
Okay, so the question is, can we do like a rename with like a lambda here? And we'll say call.upper. And it says function has no attribute keys. Yeah. So yeah, it looks like if we look at the implementation of this lazy frame, I mean, here's the rename, and it says it takes a mapping here. So it looks like that will not work. Let's pull up the documentation here. So I'm going to have to say help df.rename because my Jupyter's broken. Yeah, and so this just wants a dictionary. It doesn't look like it works with a function here. Okay, other questions? Yeah.
So it's sort of the question I asked before, but for the rename, what's the functional difference of adding that select?
The question is, what's the functional difference of adding select? So in this case, this select, well, that one doesn't work, but this one right here, this is just saying pull off these two columns, right? But can you be like, I guess the question maybe goes to like, can rename be lazy? and be sort of taken into account in the query plan. So you can just stick in a lazy in there, and like if I tried to do like a pivot, it should complain about that. Like lazy has no pivot, so you can't pivot. Let's see if we can do describe. You can't describe. So in the context of polars, you should be fine doing a rename there. The select here is just saying pull off these two columns first, right? So here's the result with the select. Here's the result without the select. Okay. Other questions? Okay. Okay, let's look at date columns here. So here's my chain that I built up, and so as again, I'm showing this process that I would do going through a new data set, and again, I wouldn't start off with this huge chain. I'm building this chain up, and so I'm showing you sort of my thought process as I'm going through the data, building this up. So in this case, I do have a column in here called time, and I want to convert it to a date time here. So I'm going to say cast PL.datetime. So let's do this, and I get a compute error. So let's just look at this compute error. It says strict conversion from string to datetime failed for this value. And then it says consider using this stir p time. Okay, so if you look at time is a string. So similar to pandas, strings have a stir accessor on them. So this is kind of an idea taken from pandas. So in addition to the things that you can do directly, if things are strings, you can do these additional things which mostly correlate with functionality that you'd find on like a Python string, right? So the issue here is, I believe there's a plus here in our date string, and apparently it doesn't like that plus when it's trying to convert that. So what I'm going to do is I'm going to try and tease this apart here. So I'm going to say like let's split on that plus, and then like I'll do an apply and pull off the first value of that. And so if you split on that, we get something that looks like that. If I don't do the apply there, this is kind of interesting. You get, if you look at this, you get a list with strings in it. Yeah. So this is, I believe, a list or I don't think it's a struct type. I think it's called a list type, and you can have like list types that are This is not like a Python list. This is like a PyArrow list. So it's kind of smart about what's going on in there. Personally, I try and avoid like nested structures inside of tabular data if I can, but you know, there are cases where you might have something that is nested, and so being able to like deal with that is kind of nice functionality to have in there. So what I kind of want to do is just pull off that first part here, and so again, this is what that looks like. So let's look at what I can do with this split thing here, and again, you can pull up the documentation here, but one of the things that's in there is this R, which is different from pandas. So this, because this is that list type, you have the ability to do array operations here. So maybe we can come in here and say like, let's inspect what you can do with an array here. So these are kind of like listy things that you would do with a list, right? So that's kind of cool. So I'm going to say just split it and then get the thing that's in the 0 index here. So that's, instead of doing this with this mechanism up here, saying apply a lambda, this would be the polar's way of doing that, saying array.get0. Yeah, you're crossing that Rust Python boundary, right? And so you're kind of losing your speed benefit when you do that. Okay, so let's try this now. I'm going to say pull off that first part and then cast that to a date. And I still got an error. It says it failed. And it says if you're using, trying to cast a string, UTF-8, to a temporal type, consider using stir p time. Okay, so maybe I should take their hint that they're giving me and use this stir p time. So now my chain looks like something like this. I'm going to take my time, I'm going to split it on plus, I'm going to get the left-hand side of that, and then with that should be a string, and then I'm going to say convert my string to a date, and this is the type, and then this is the format that is in there. Let's try that, and that looks like that works. So yeah, this is, again, if you're coming from like Pandas, this is maybe a little bit more involved than Pandas parsing that. You could probably just stick that into a to-date time in Pandas. But this, you know, they want us to be explicit, which, you know, if you are explicit about like these date times here, these strings, it makes it easier to parse. And I get, like, if this is implemented in Rust, then yeah, forcing us to do things that make it easy from the Rust side kind of makes sense. So my chain would be updated to something like this, where I'd say, okay, now I want to have this time column, which is this chain of splitting that up. So let's just run that and make sure that that works. And it looks like time is now a time column there. Okay, and I'm storing this in df2, so now I have this df2 thing. Now, because I have converted that to a time, it also has a dt attribute here. Right, so we're seeing similar to Pandas. Pandas has DT attributes, it has STR attributes. It doesn't have ARR attributes, but there are various date manipulations that we can do on this now that it's converted to a date. Like we can say, what is the month? And this is kind of nice. We have this functionality. You know, could we pull this out of the string? Yeah, you could use a regular expression or whatever to pull this out of the string, but it's super nice here. Let's try and convert the time zone here, and here's the documentation for doing that. So I'm going to say replace time zone, and we'll put it as UTC, and so now it is in UTC. And then if I want to like convert that to America Denver, which is the time zone from where I tweeted, I might do something like this, where I say convert it to UTC first of all, and then convert that to America Denver. Okay, so yeah.
I noticed the time zone, the daytime object is daytime microseconds. In Pandas, I think I would see it as daytime nanoseconds, like NS.
So the comment is that this is microseconds instead of nanoseconds versus what it would be in Pandas. I don't know off the top of my head. I mean that, I guess that is one of the nice things about being precise about that stir p time, is that you can like tell it what it is. But yeah, I guess maybe the comment is more like if I've got like things happening at some very small granularity, maybe I'm doing particle physics or something, maybe this is not the appropriate mechanism to keep track of the granularity of that time. Yeah, I'll say I don't know. I haven't explored that or am super well versed in things that are very small points of time, but that might be something to consider. Okay. Let's do another exercise here. So create a series with the months of the time column, and then convert the time column to UTC, and then convert the time column to America, New York. So again, just want to give you some practice in addition to just running those cells, writing out some code, and doing that as well. So I'll let you work on that for a little bit, and if you have questions or need help, let me know. And then I'm assuming we'll go straight into our break, since it's like 10:22, and I think our break is at 10:30. So I think we'll work on this and then probably jump into our break. Okay, hope everyone had a great break. Okay, let's look at this date exercise here. Says create a series with the months of the time columns. So if we look at this df2, we do have that time column in there. So I'm going to say df2, and we can say select to select columns. So I'm going to say select, and then what column do I want? So I'm going to say PLAll, and then I'm going to say time, column name. So this is the time column. Because that is a date column, it should have a DT accessor, right? And I'm going to say select the month. And if I say select month like this, I think in Pandas this is a property. In this case, it says it did not expect a bound method. So what does that mean? Month in Python is an object, right? It's a method. And apparently pollers, you can't put a method inside of a data frame. In Pandas you could actually. But you can't do that here. So we actually need to call the method, and that should be that. I think there's a month name as well. Let me just check here. Maybe it's month underscore name. Okay, there's not a month name in there. Yeah, question?
And if you wanted to persist that as a new column in your data frame?
Yeah, if we wanted to persist it as a new column, then we would use the with column, right? So let's do that. So if instead of doing the select there, I'd say with columns. And if I did this, whoops. What this did was, yeah, this actually overrode our time column. So I might want to do something like this where I say alias and say this is the month column. So that keeps the time column in there, but we should have a month column. If I can scroll over here, right there. Okay. The next one is convert time column to UTC. So since we're doing this in a data frame, I'll just do this in the same one here. I'll just say, okay, let's make a time column that's UTC, which is this replace time zone UTC right here. So I'm going to say PL.call.time.dt replace time zone. And now it's in UTC right there. Again, if I want that to be a new column, I can say alias, and then I can say this is the UTC time. You see, there's UTC time. Okay, and if I want to convert that to America time, so in Pandas you could do something like this where we would say PL.call, and then I could say, like, let's take UTC time, and let's do it on that. I want to do a DT dot replace, not replace. That is not replace. It is convert time zone. So we'd do a convert time zone, and we'll see America, New York. And when I do that, I get an error here, column not found. So let's look at that. It says there is not a column called UTC time. What's going on here? It's saying you should have a column called UTC time, but I don't. That's because I just created that in this with columns call here. So in Pandas, you can get around that by using a lambda. If you use a lambda with a sign, you can get around that. Let's see if we can get around it by just doing another call to with columns. And I'm going to alias this as NYC. Okay, so that looked like that worked. So if you want to refer to a column that you just made, you'll have to do a new with columns call. Does that make sense? This UTC column is the result of this previous with columns up here. Alternatively, if I wanted to, I could just take this whole thing and tack on this onto the end of it, and I wouldn't have to do a new call to with columns. Okay, questions before I keep going? Yeah.
When you run this code, it does give you the full row set, and you could always do a head, add a tap on the head at the end to get the content. But what if you wanted to get the rows between the 20th and the 30th, that kind of slicing? How would you?
So the comment is, you could do head to get the first number of rows, but what if you wanted to select different rows, not the 20th and 30th? So there is a filter. So select lets us select columns, filter lets us select rows. And so in that case, you would need to have some row that you could filter on, right? So if you wanted to do it by position, like Pandas has iLoc, right, to get the 20th row, then you'd have to make a column that has the row count in it, and then do a filter on that column. Yeah, so we don't have, again, we don't have the index there, so we'd have to use something like that. Yeah, it has, I've got an example here that will show you how to emulate the index down below and insert that in there. Okay, so after I've done this, I feel pretty good about what I have. I would go out and make a function that looks something like this, right? And so this is my tweak Twitter function. This is taking the raw data and cleaning it up. And again, I would make a chain like this. I would do this in Pandas as well. In polars, it's kind of encouraged to do a chain. In Pandas, you don't see that a lot, but again, polars, because it can be lazy, can do some smart things about this. So if this, if I was working for a client, what I would do is I would take this code here, and I would put this right at the very top of my file, right next to where I load the data. So what this does is it reads like a recipe. Whoops, I'm working with the raw data, and then I'm saying, okay, I'm going to convert these columns to integer 8s, these to unsigned 16s, this one to an unsigned 32. At this time, I'm going to convert it to America time zone, and then I'm going to select these columns, and then I'm going to rename the column names. All right, it looks like the series of steps that I'm going to do. Let's just run that and make sure that it works, and it looks like it does. Okay, so this is also called chaining. In Pandas, I'm a big proponent of chaining. A lot of people say that it's ugly. Again, I think they don't see that I build up the chain as I'm going. I don't just write a big huge chain. I'm building it up as I'm testing it as I'm going. And I'm doing the same thing here in polars. Now polars does have the added benefit that it does have this laziness, right, where we can say, let's be lazy here. In that case, it's not going to materialize these operations until I call collect at the end. And so if there are, it does have a query optimizer, so to speak, like a database, and so it can go in and be smart about how it's doing these things. But this should give me the same result as the one up above, but it should possibly be a little quicker. In fact, let's just do some timing here. And I'm going to time my lazy Twitter against my non-lazy one. And we'll see what happens here. Okay, so my lazy one took 1.3 milliseconds on my machine. It's a MacBook Pro from last year or whatever. My non-lazy one took 1.47. Now, again, there aren't a lot of places for optimization here, so to speak. I mean, I'm just sort of pulling off columns and converting them, where the query optimizer can't really do a lot of optimizations here. Now, what I'm going to do in this example is I'm going to actually add file rating into this. So here, instead of passing in my data frame, I'm going to pass in a file name, and I'm going to say scan CSV. Scan CSV is lazy, so it's not going to read the CSV. It's just going to say, I have this CSV file up here. I don't think I actually need this lazy down here because I think scan CSV is lazy. Oh, it says I don't have file. Let me get file here. So I have a local file right here. Okay, so so if you don't have that, I don't believe that works with URLs, so you do need to have that local if you want to try that out. So let me scroll back down here. Okay, and that looks like it works. Again, if you leave off that collect there at the end, it's going to give you this query plan of what it's going to do. So again, there's not a lot of like fan out or group bys where it can do a lot more operations here. But let's just time this. So right now, without collecting, it takes 200 microseconds. If we do collect it, let's time it like this. And it takes 2.7 milliseconds to run. Now this is including reading the file, right? So this is not just doing the operations, this is reading the CSV file. So it takes 2.7 milliseconds to run. I'm just gonna, down here I've got a Pandas comparison. And I'm gonna read my Pandas file and do this. So in Pandas, this takes 38 milliseconds. In PLAll's, this takes 2.7 milliseconds. So quite a bit faster here. Again, this is milliseconds, so it's not a huge deal. Like 34 milliseconds versus 2 milliseconds is not a huge deal. But if your data gets bigger or you have more complicated operations, you can see where you might be getting some benefits for this. Okay, so this example is just showing the plan here, and this is what it can go through and optimize after this. Okay, so one of the things that people complain about chains is they complain about that you can't debug them. So I think we'll do this exercise together. This exercise is use pipe to print the shape of the data frame after every step in the chain in the tweak Twitter function. So a lot of people, when they see like a function like this, they're like, I can't understand what's going on here, which, whatever. I get that like it might be overwhelming, but once you like learn a little bit of PLAll's, it's not too bad. I sort of feel the same way about Pandas. But what I want to do is I want to use a pipe here, and I want to debug this. So one of the things that people claim is that they want to look at the intermediate variables. And I don't personally want to do that. I want to have my input and my output, and I don't care about what's made along the way. But let's assume that you did, or maybe your data changed and you need to look at that. And so one of the things that you could do is something like this, where you can say like def, and let's say debug, and we're going to take a data frame, and maybe we'll take extra, and what I'll do is I'll just say print, I'll use an F string here, and we'll say extra, and then we'll say df.shape. And then we'll return the data frame. Okay, so what I'm going to do is I'm just going to put this right in here, and I'm going to say .pipe, and I'm going to say debug is the function I want to call. I'm going to say extra is equal to start. Okay, let me just run this, and you can see that now it's putting out start there at the top. Okay, so what I can do is I can just, so this is kind of nice, especially if you're doing like joins or whatever. I can say like, okay, after I've updated my columns, let's look at the size, update columns. And then here I've selected my columns. And the last one is a rename. It's not going to do anything, but you could imagine if I had a filter or whatever, it might do something. So there you can see that I'm starting off with 5,791 rows and 40 columns. After I update my columns, I still have 40 columns, and then after I select my columns, I have 22 columns. But something like this is especially nice if you're doing a join. You can see if you do like a combinatoric explosion in there or something to catch that. Scroll back up there so you can see that code again. All I'm doing is making a function that takes the data frame as the first input, and it's returning a data frame. That allows me to stick it inside of one of these chains here. And then I'm just having a side effect of printing that out on the side there. Any questions about that or comments? Okay, I mean, if you wanted to, you could go beyond this. You could say, let's do the same thing, but instead of printing out to the screen, I'm going to make a global variable and update the global variable with the current state of the data frame if you wanted that current state of the data frame to inspect it. The question is, could you do that inside of the with columns? Yeah, I don't know that that would work inside the. I don't know that with columns will take a callable to do that. So that wouldn't really work. But yeah, I guess you just sort of have to treat with columns as sort of its own box of operations. Okay, so we did this pandas comparison here. One thing to be aware of is like this would be like my pandas code to do what I'm doing. You know, which code is better? I'm just honestly more familiar with pandas. I've used it a lot more, right? So to me, this code is perfectly fine. To a lot of people, like it is doing some things, like it's doing some dictionary comprehensions with unpacking in there, which a lot of people aren't familiar with. We are using like lambdas in here, which in pandas I'm perfectly fine with. But I mean, I can read this as a recipe. I'm going to rename my columns. I'm going to replace spaces with underscores. I'm going to drop these columns in here. I'm going to also drop these other columns, and these are the promoted columns, so this is just me not having to write out promoted in there. And so I'm using a list comprehension to drop out those promoted columns. Again, if I wanted to go through that positive thing, I might do this and then select my columns and go in and say positively select these columns. And then I'm converting my impressions column, I'm converting my engagements columns. All of these columns I'm converting to unsigned integers. All of these columns I'm converting to unsigned integers as well. This tweet permalink here, I'm converting that to a category, which I didn't do in polars. And this one here is the date time conversion. So I think it's a little bit less code, or at least a little bit less of vertical lines. But again, a bit faster in polars. Okay, so let's look at doing some manipulation of columns here. So here is my twit df here. Let's assume that I want like an engagement rate as a percentage. So what I'm going to say is I'm going to say take my engagement rate column, and then let's apply this function right here, the percentage function. And we'll call that the engagement percent. And if we do that, we now have this engagement percent right here, right? So what's the engagement percentage of that? Well, let's just do a benchmark of that. And then I'm going to do a benchmark of this where I'm taking the expression and multiplying the expression by 100. Okay, and you see that we've got a pretty big performance difference here. So top one here, 500 microseconds. This one here, 55 microseconds. Again, this is microseconds, but it is 10 times difference. Will that pan out to larger data sets? Maybe, maybe not. Again, general benchmark advice is to benchmark against the size of the data that you use. one of the things to be aware of is this apply. When you're doing apply, that's element-wise, so you're pulling off the individual values. You're crossing that Rust Python boundary when you do that. So here I'm saying, let's do apply with np.sign. PLAll does have a map, and so map is column-wise. And so you can see the difference there of np sign versus map of sign, applying np sign versus map of it. It's like 2 milliseconds versus 200 microseconds, about 10 times faster there for this data set. And again, unlike Pandas, PLAll actually has sign in it itself, so you don't have to do any of this. You can just say .sign there to get the sign of that. Just for fun, I'll import the math library and look at calculating the Python math sign function here. You can see that PLAll is going to be faster than using NumPy and doing math.sign. In this case, math.sign is faster than using NumPy, which not quite sure why that is, but yeah, probably because it's, well, yeah. I would think that converting to NumPy would be faster than converting to Python and applying math.sign to it, but apparently something's going on there. Okay, so another thing you might want to do is manipulate your string columns, right? And so here I'm saying I want to determine whether a string, a tweet is a response, and so a response tweet to someone else would start with the @ sign. And so in Pandas you can do this, stir.startsWith. In PLAll there is not a starts with. So like Python has starts with. Let's look at the attributes of str. And for whatever reason they named the starts _with, which it is what it is. I mean, is like starts with without an underscore there the world's best naming? Probably not, but I mean, it's the convention in Python, and Pandas is sort of using it. So whatever, I mean, it is what it is. So some of those things might not be exactly the same. So let's do starts with that, and we'll just do a timing here of that, and we're going to compare that with an apply, where we're pulling out the value and sticking it into a Python string and doing that starts with there. So generally in Pandas, my advice is avoid apply. However, if you're using strings in Pandas and you're not using the PyArrow strings, you're going down a slow path anyway generally in Pandas, and so apply might make sense for strings in Pandas. In PLAll here, you can see that a lot of these things are optimized in PLAll, and so you get quite a big speed performance here by doing this with an expression. If you can do it with an expression. Okay, so I might update my tweak Twitter to look something like this now. If I'm going to do like some machine learning or some further analysis on this, I might want to look at my tweets and pull off various features from that, right? So here I'm not going over all of these, but I'm doing things like I'm going to make an isReply column. I'm going to make a length column that's just taking stir.lengths S. I'm not sure why it's spelled lengths, but that's the naming there. And then I'm going to make whether it's an @tweet, whether it has new lines, whether it has the number of lines in there. And so you can say I'm doing like stir.contains, stir.contains, stir.countMatch, stir.contains. Okay, and then I'm also going to put some other columns here for time. I'm going to get like the hour when I tweeted, the day of the month, and the day of the week, just to see if I'm doing some machine learning or further analysis, whether those have an impact on what's going on there. Okay, and you know, I can run this and inspect this, and it looks like this is working. Okay, so I want to give you the chance to work with apply here. So we're going to do this, calculate the engagement ratio by dividing engagements by impressions, and then calculate engagement ratio 2 by dividing the sum of replies, retweets, likes, user profile clicks, and detail expands by impressions. So I'll let you work on that for a moment, and then we'll go over that. I'm going to give a hint for this first one that might just sort of help. I'm going to say I have like this twit df here, which has gone through my tweak df. So I do have this twit df here, and I want to make a new column. So I'm not going to make this ratio one, but to make a new column, I say with columns. Okay, and then let's say instead of doing the ratio, I'm just going to say I want to, maybe I had a good day, so I'm going to have the double engagements column, right? So how would I do that? I would say call, I want to make an expression, and so PLAll.call, right? And then we'll take engagements. And if I want to double it, I want to multiply it by 2. And so these expressions respond to Python operators like this. And it says incomplete input. It wants that parenthesis there. So this is engagements multiplied by 2. And if I wanted to name this as like double engagements, I would do like an alias here. So alias, I'll just call it double ENG. Now that doesn't work because it's like int doesn't have alias. That's because of operator precedence here. So what I need to do is just wrap this inside of a parenthetical here. Say, do the multiplication, which should return another Polar's expression. And then once I've done that, alias that expression. So now you can see that there's the double ENG right there. Does that kind of give you an idea or some boilerplate for what I might want to do for doing that? Oh, yeah. Well, mine have underscores in them because I'm using twitdf. But yeah, yours might not. So yeah, you can do it either way. Okay, so hopefully now, again, I like to have the exercises here because it's one thing to watch me talk about it and it's like, oh, it goes in one ear and sort of makes sense. But then when you actually do it, that's like where it goes into muscle memory, right? And science tells us that if you actually do the exercise, you'll learn it a lot better because you're going to understand it better. Okay, so I'm just going to do this here. So I've got with columns here. So I think I can put in a bracket here, and I'm just going to tack on these other ones in here. So I want to divide engagements by impressions. So I'm going to do that here. I'm going to just come in here and say take engagements and divide it by PLAll.impressions. Okay, so that looks like that worked. It turns out that because, I guess this is Polar's just takes, it looks like it's just taking the first column here and using that as the name. So it looks like it has updated the engagements with that. So I don't want it to update that. So again, same thing here. I'm going to come in here, wrap this with parentheses so that I do that whole expression. And then I want to alias the result of that. I guess alternatively, I could come in here and say like alias this as the ratio in here. But I kind of like to keep that math separate, like do the math and then do the alias. So we could call this like the ENG ratio if we wanted to. And now we should have that over here on the side. Okay, if we wanted that to be a percentage, we could multiply that by 100 to make it a percentage. The next one is calculate it by summing up these columns and then dividing that by impressions. So this is just another example. You know, do I need to use a list comprehension? I mean, maybe. There is a way to do a sum column-wise. I don't recall off the top of my head what that syntax is. So I'm just gonna manually write this out. So we're going to take replies, and we're going to add pl.call.retweets. And we're going to add PLAll.call.likes. And because I'm inside a parenthetical here, I'll just go to the next line. We'll add PL.call, user profile clicks, and we will add PL.call detail expands. So this it should be, according to Twitter's definition at some point in time, this should be the same thing as engagements. It's summing up these columns here. So I could come in here and say, like, alias this as eng ratio 2. This should be the same as engagement. So engagements is like 7 and 3. So it should be like 7 and 3 over here. So it looks like that is matching. So again, showing you how I would build this up and test it as I'm going. And then we want to divide this by the impressions here. So we've got that sum. We want to do the sum first, and then I'm not sure if there's a divide method. Let's just try it and see. There might be one. There might not be. We'll divide it by PL.call and impressions. Okay, and it's claiming that parentheses are off, so let's do that. It looks like that doesn't work. So I'm going to actually come in here and put that there. I'm not seeing eng ratio 2. It's probably because I think I need an extra parentheses around this right here. Okay, there it goes. And it looks like those are the same. So looks like we're good there. Okay, so the point of this is that similar to Pandas, if you can, you want to do those math operations directly at the Pandas level or the polars level. It keeps it fast rather than jumping to an apply, which might be maybe I would say the naive way to do it, but is going to be slow. Okay. I think with our remaining time, we're going to look at aggregation. And aggregation is, I like to say aggregation is what your boss wants, right? So, you know, it was spring break the other day, and we went to a candy store in Jackson Hole. It was like a tourist trap, but it's just a bunch of candy, right? And weird candies and whatever. And I imagine that the boss of that candy store doesn't come in and say, tell me what happened today. And someone comes in and says, well, Susie came in and bought 1 lollipop and two sticks of gum and then a gummy bear, and then Billy came in. Your boss doesn't want that, right? They want to say 58 people came in, they spent $2,368, right? So they're going to take all of that information and collapse it to a single value. Generally, when your boss wants something, they want some sort of aggregate. And so that's what I like to think when you're thinking reports. Generally, you're thinking some sort of aggregate, right? I mean, some people say they want the details. They don't really want the details. Generally, they want the details to make sure that you did your calculations correctly or something like that, or dive into that. But really, they want these aggregations. So now let's look at some of these aggregations here and how we might do that. And generally, how you're going to do that is either with group by or with pivot. Okay, so here I'm going to say, let's take my Twitter data, and then I'm going to say I want to group by, and look at this, I'm putting an expression in here. So I'm taking the time column, pulling off the year, and then aliasing that as year, and then my aggregation function here is going to be take the mean of that. Okay, and this is the result here. Now in Pandas, you would see year in the index. Here we don't see that, but we are seeing that we have that alias year. Let me just for fun take off the alias. And we get an error here, it's duplicate error, right? And so why is it complaining about duplicate error? Because we're using the time column, and apparently it has more than one occurrence, which is a no-no in polars land. So we want to stick that alias in there, so we don't get that. So it's going to stick that, instead of making an index, it's going to make a new column called year, and then we have for every entry there, in this case it is including strings as well, it's giving us the mean value. And I should note as well, this is a place where you can get improvements, kind of two places in pollers. One is that pollers, when you do grouping, pollers can maximize those CPUs, right? So if you have multiple groups, it can do parallel operations on each of those groups because they're independent. And then if you're doing a lazy operation, it can further go through and figure out if there are other optimizations that it can make before it does the grouping, if you're doing lazy. So this aggregation, this reporting is where you're going to see probably your most sort of bang for your buck if using pollers for performance is kind of what you're looking for, or if that's your motivation for using pollers. Okay, so there's a question, how do I get the index in there, or simulate the index? And so there is this with row count. So let me just show you that. I'm just going to comment out these other things here. You see that this sticks in this thing called row NR. Okay, so you can think of that if you're used to Pandas as an index here. So we're going to group by here. Group by, just like in Pandas, is lazy. It doesn't do anything until we do an aggregation. And here, in this case, I'm going to call ag. And in this case, I'm passing in a list of expressions, right? And so this is another place where pollers can be smart about this because we're passing in multiple things. It can say, oh, I'm going to do these at the same time if I have the CPUs to do them. So in this case, it's saying with the impressions, take the mean value, and with this number row, take the first entry for that. Okay, so you see that there's number row, the first entry for the 2021 year was this value right there. So the question, going back to that question, like if I wanted to see row 20 or something like that, like 20 through 30, I might do something like this. Or I might say, okay, let's do a filter here. Filter lets us filter rows, and then we can say PLAll, and this should be row NR, and I should be able to say greater than or equal to 20. And I don't know if this works this way. I don't know if it works like this. It might. Let's see if it does. Okay, since expressions are lazy, the truthiness of the expression is ambiguous. Oh, okay. So this is doing less than 30. So it wants us to combine it. It wants us to do something like this. Less than 30 and PL.call row NR greater than or equal to 20. Okay. So there's rows 20 through 30. So a little bit more verbose than what you'd see using like a Pandas or a Pandas iLoc to get that. Okay, so let's go to our next example here. We're grouping by year, and we're getting the mean impressions and the mean replies by year. So we want to say, like, how are we doing by each year? And we see that, you know, for 2020, 1,000 impressions on average. In 2021, we're getting 3,000. And then we can also see that, like, our replies went up a bit per se as well. Now, again, because we are doing these different aggregations, this is a place where pollers can be really quick, especially relative to just Pandas the library. Okay, so let's assume that we want to do, instead of just by looking by year, we want to break this down to finer granularity. Let's do month and year. Okay, and so it turns out that you can pass in a list of expressions into the group by here. So I'm going to say I want to group by year, and then I also want to group by month in year. And so let's run that, and we get something that looks like this. Now, if you look at this, the result here might be a little not satisfying here because it's going from like April of 2021 to August and then back to June of 2020. So the results are not sorted. And that's due to how Polars is doing this by default. It's doing what's called a hash join. A hash is unordered, but it's fast. And so it gets that done quickly, but it's not necessarily ordered here. So we might need to do some further operations. So we might say, like, let's sort this by year and month. Again, we don't have an index, so we're just going to sort it by the columns. And we get something that looks like that. That looks like that's decent. Okay. Another option here is to pass in this maintain order. Okay, and so we'll pass in maintain order here, and that looks like that works as well. So that's just telling the grouping, hey, I want you to maintain the order. And again, according to Richie, the creator of Polars, this is preferable to calling sort. Apparently there are some optimizations that can happen by knowing this at this point rather than just calling a generic sort after the fact. Also, there is a fast path in Polars. So if you call sort on a column, Polars will know that it's sorted and it can do further operations. And you can, if you think about that, I mean, if you've done a data structures class, if you have sorted data, it's easier to merge sorted data than data that's not sorted. And so it can take advantage of that. So here we're going to say, I want to sort this, but I'm also going to do this. I'm going to say, let's make a column called month, but the column is going to be the year and the dash with the month in it. So rather than having, like this one up here, had year and month as columns, rather than having two columns, I just want a single column that represents that. And so I'm going to do that, and we'll get a result that looks like this. And here, month is this string right here. So that's looking okay as well. That might be preferable. Now, if you've used Pandas, you might be familiar with Pandas. Has the notion of an offset alias. Anyone familiar with that? Offset alias is where if you have a column that is a date, you can say, I want to resample this at the quarter level, and it will take everything from the same quarter, and then you can do an aggregate on the same quarter. Or you can say, I want to do everything from the same week, and it will give you each week. Polars has something similar. It's called group by dynamic. And so you can do something like this, where this is kind of interesting. You say index column, even though there isn't really an index in Polars, but you say index column. So we're going to use the time column, and then I'm going to say every, and this says 2MO. This stands for 2 months. So let's run this. And if you look at this, in this time column now, what you have is instead of having a string like we had in that previous one, we now have a date time. Okay, and if you look at the date times here, this is January 1st, this is March 1st, May 1st, etc. So this has done the aggregation using date manipulation. If you think about this, this actually is just doing an aggregation based on these strings that I created, but this is a little bit more intelligent down here. Okay, so you can do crazy things like this. Look at this. I'm going to do every, and I'm going to do 2W, that stands for every 2 weeks, and then I'm going to do every 3 days and every 5 hours. Kind of silly, but the point is that, like, this is kind of powerful too, right? If you wanted to do aggregations by different frequencies, you can do that. And if you look at the date, the first one here is January 1st, and it's like 2044, and this next one should be like 2 weeks later and 3 days after that. And it doesn't look like that's 2 weeks later. So apparently there's a bug in here. So maybe we found a bug. Okay, or maybe I have a bug. Maybe my 2 weeks is not right. This looks like 3 days. So maybe my weeks is messed up. Let me just for fun here. And I'm going to say 2W. Okay, so apparently it doesn't like combining dates and weeks, and apparently the dates supersedes the week entry there. Okay, so I guess if we wanted every 2 weeks and 3 days, right, we could say 2 weeks is 14 days, and we can make this 17, right, which should do what we wanted there. Okay, so oftentimes when I have this, right, I mean, I think this is you know, is this the best information ever? I mean, it might be, right, but I might want to plot this as well, right, and plotting is another way to visualize it. I'm a huge fan of plotting. Sadly, Pullers, or maybe not sadly, depending on your point of view, Pullers doesn't have plotting in it. So if you want to do plotting, you need to use some other library. One of the reasons I really like Pandas is because I think like using Pandas lets me create plots in Matplotlib a lot easier than Matplotlib itself. Actually think once you understand the interface of Pullers, or sorry, once you understand the interface of how Pandas makes plots, it's really easy, especially if you're using an aggregation, to go from an aggregation to a plot. And so I might want to look at like a time plot or a line plot of this data. And what would I want? I would want this time to be in the index, and then I want impressions and replies to be a little line for each of those columns here. Really easy to do in Pandas. So let me just show you how we might do that. We can actually say, send this over to Pandas. And so we can say to Pandas, this is now not a Pullers data frame, this is a Pandas data frame. And in Pandas, if you're doing a line plot, by default, it's going to plot the index in the x-axis. So I'm going to say stick that time into the x-axis. And now that is the index. You can see it's bold there. And if I just call plot here, it's going to plot the index in the x-axis, and each column will be its own line. Okay, so here is my plot from that. Maybe I come in here and say fig size is equal to, and maybe just make this a little bit smaller, 8 by 3. Okay, so that's every 2 months here, but if I wanted to do like every 3 days, there's every 3 days, right, or every 7 days. So this makes it really easy to see that like in July of 2021, something happened there where impressions like shot up, right? Okay, and so this is just showing what I just showed. I'm just changing the frequency there, so you can change it to kind of play around with that. But super powerful. I mean, once you sort of understand this every parameter here, again, Pandas calls this an offset alias. I'm actually going to pull up the documentation here. One thing I don't like about Pandas is that the offset alias isn't documented in documentation that you can access from Jupyter. Let's see if that's the case here. Okay, yeah, so here's the offset arguments right there. Cool. So kudos to Pullers for actually including that documentation in the library itself that you can access from the library. Okay, let's try and do a pivot. There's also a pivot. In Pandas, pivot is basically built on top of group by. So here is, there's a pivot, and this looks pretty similar to Pandas. You say the values, you say what goes in the index. Again, there's no index in Pullers, but that's basically what you want to group by. So if you're not familiar with Pandas, that might be a little bit weird, but basically the index is what you want to group by. And then you can say what columns you want to be in the output, and then you can specify an aggregation function. Okay, so one of the things that's sad about this is that, or what I kind of miss is that we can't use a dynamic, there's no dynamic pivot per se. So if I'm making a pivot table and I wanted to do like dynamically by every 3 days and 4 hours, I can't do that with a pivot, with the pivot function or method itself. So I would need to come in here and do something like this where I use stirf time and then with that new column, tell it to aggregate by that new column. Okay, so here what I'm doing is I'm just saying, okay, I'm going to make a new time column, which is year and month. I'm going to pivot based on the month. I'm going to pull out the values for impressions, and then I want columns to be whether it's a reply or not. So this is, what is this telling me? This is telling me, do I get more impressions if something is a reply or if it's not a reply? And so we've got like a true-false column. True means that something is a reply. False means that it's not a reply. And it looks like, in general, if it's not a reply, I get more impressions, which makes sense. Twitter doesn't really show your replies to everyone, only if someone is following both of those people. So that would make sense. Okay, in this case, I'm saying let's look at, so up here I just did, let's look at the impressions. Here I'm saying let's look at the impressions and the replies. And then I'm going to aggregate, or I'm going to, my columns is whether something is a reply or not. So what do we have up here? We have, here's something that is a reply, false for impressions. Here's is a reply true for impressions. Here's replies that were replies, and here's replies, sorry, here's replies that were false, and here's replies that is a reply was true. So this is, kind of need to think about this, like what does, if something is a reply, but the call, we're aggregating the replies for something that is, oh, okay. Yeah, so the, replies is the number of replies, and this is an indicator of whether something is a reply. So it's possible for replies, something that is a reply to have a reply on it, basically what that is saying. So yeah. The column headers here might be a little bit weird, right? I mean, it's building these up for us. In Pandas, we would have hierarchical columns here instead, which might make it a little bit easier to understand. But again, Polars doesn't have hierarchical columns, so it's kind of just building those up based on the values that are in there. Now, you can do something like this. You can say, like, I want to specify the separator in there. So instead of, you can see how it's kind of building that up. This is the impressions column, and then we're looking at whether is reply is false. This is the impressions columns, whether is reply is true. The replies column, whether is reply is false, and the replies column, whether is reply is true. And this is just saying stick in a star as a separator. You know, if you want space in there, you can stick in a space. And that would work as well. And then here, let's just plot this here. So, whoops. So we're going to set this, we're going to convert it to pandas, stick that month in there, and then we'll plot that. We get something that looks like that. Okay, so we're going to do our aggregation exercise, let you work on this for a little bit. Let's just look at the exercise. The first one is what were the total impressions for each year? So hint is when you hear something that say for each year or by something, that's what you want to group by. Okay, so in this case, if we want the total impressions for each year, we need to group by the year, and then we're going to pull off that impressions column and take the sum of it. In this case, total impressions for each month, we need to get the month and then sum the impressions. So once you have this first one, hopefully that second one is not too hard. This plot the previous, so just visualize those. And then the next one here, what is the total impressions for reply and non-reply tweets for each month? So that one's a little bit more complicated, and then plotting that. So I'll let you work on those. And again, just if you have questions, concerns, happy to go around and help. But this is, again, your chance to get some of that muscle memory. I've found that Grouping and aggregations, these pivoting, is probably some of the most important things that people need to be able to do with their data. And it tends to be one of those things that, again, the more you practice it, the easier it's going to be. Like, this is one of those things that you need to get the muscle memory to really start understanding how it works. So I'll let you work on that for a little bit. Questions before we hop into this? What questions do you have? Okay. I'll just be quiet and let you work on it. Okay, I think we're gonna look at the solutions here for this, as we're getting to the end of our time here. Okay. So first of all, what were the impressions for each year? Okay, and so we got a couple options here. One is we can pull off that year column and that year value from the date and put that in there. The other is we can do a group by dynamic. So maybe let's do a dynamic one. Okay, so I want each year, so I should be able to say Y here. Yeah, so it says expected an integer in the duration string. So it wants us to specify how many years. So if you look at this is the January 1st of 2020, and this is January 1st of 2021. So this is a little bit different than Pandas. And Pandas with an offset alias, you don't have to specify a number there, but looks like PLAll wants us to. Okay, so, and we want the impressions for each year, and we want the total. So I've got replies in here. I don't want replies, and then I want this to be the sum here. Okay, so there's the sum of the impressions for each year. Okay, if I wanted this for each month, once I've got it in this form, it's really easy. I just change this to 1M, and you can see this case that didn't work. That looks like it's probably doing some sort of minute there. So we'll try MO, month. That looks like it did work. Okay, so now both of those work. The next one is to plot these. So again, PLAll doesn't have plotting, so we'll convert that to Pandas, stick that time into the index, and if we just call plot there, there we go. That's not particularly interesting. I would probably prefer to do a bar plot on this. Slightly more interesting. I might even do a horizontal bar plot, change that to a bar H, something that looks like that. This one here probably would leave as a line plot. Let me see something that looks like that. Okay, let's see. The next one here is what were the total impressions for reply and non-reply tweets for each month? Okay, so in this case, we're going to do a pivot on that. So I'll take my pivot code and copy and paste it. And I already have each, this is the month code here, and so I want to stick that into the index. What do I want to look at? I want to look at the impressions, and I want the columns to be whether it's a reply or not. So that little tweak of that should be okay. So I'm not afraid to like take code and run with it. Again, like getting this code started off might be a little bit more involved. So start with something simple, right? Start with something simple that you can check and make sure it's working, and then build that up. So let's plot this. So we'll convert it into Pandas. Let's set the index to the month, and then we'll plot this. Oh, thank you. Yeah, aggregate function to be the sum, total impressions. Yeah, and there we go. We get something that looks like that. Okay. Questions, concerns, thoughts? Okay. So we are at the end of our tutorial here. Hopefully this gave you a chance to play around with pullers, see some of the places where it might be different or improve on other libraries that you're familiar with. Again, sort of the elephant in the room is Pandas. My take on this, again, I'm pretty biased because I've used Pandas for a long time. My take on this is that, like, I feel like I'm very comfortable with Pandas. The expressions for pullers take a little bit of getting used to. It seems that pullers requires a little bit more typing than Pandas does. That might be a trade-off that you're willing to make to get the speed performance. Again, a lot of that speed performance is going to come when you start doing aggregations and groupings, where it can be smart about that. Pullers also, because of the streaming functionality that we didn't have time to go into, but it does have some streaming functionality, can do larger than memory data sets that Pandas, the library, can't do, but again, Pandas, the API, can do with various other libraries that implement Pandas that allow you to go out of core. I do like to, so I showed my method for like taking a data set and going through it and analyzing it. I do like to do that. Just go through the columns, check those types. Again, when you're using libraries like Pullers or Pandas, going through those types can be often a significant memory savings by doing that. And that's can also speed up computation time as well. Huge fan of chaining in Pandas, but also chaining in Pullers. You don't have to chain, but you're kind of going to get dinged or penalized in Pullers if you don't. So you can get performance boost in Pullers by doing chaining, especially if you're lazy, because it does have query optimization. So embrace chaining. Again, when you go across that Rust Python threshold, things will slow you down there. So find ways to do things in expressions if you can. And then finally, these aggregations that we looked at are very powerful and let you answer questions very succinctly. The syntax might be a little bit confusing or weird to you. If that is the case, my advice is to practice them, right? The more you practice these aggregations, the better they're going to make sense, and you'll see sort of the pros and cons of them. Okay, any questions before we dismiss?
So just the general one of, if you're somebody who's already reasonably happy with Pandas and you don't really care about Rust and your performance is okay, is there a good reason to think about Pullers?
Yeah. Question, like, if I'm happy with Pandas generally, I'm not having performance issues, I'm not, like, Rust isn't super interesting to me as a language, do I need to care about Pullers? I mean, and my sort of short answer would be, if Pandas works for you, you should be good. Again, Pandas 2 just came out a few weeks ago. It does have the ability to use those pi-arrow data types, which is going to get you both speed and memory improvements from that point of view. You know, for doing exploratory data type stuff, Pandas is going to have better integration with other libraries, right? Because Pandas has been around for a while. It's sort of the big player there. So yeah, if you don't have compelling reason to use Pullers, I don't think there's a need to switch to it per se. I guess my take on that would be, like, I do think you would want to, at least if you're coming from Pandas, to probably start embracing that chaining, because even though you don't have like query planning and optimization that you do in Pandas, I do think it makes your code easier to read and debug and reuse. So that would be my advice around that. Other questions? Okay, well, thank you for your time. Hopefully you feel like you are better prepared to sort of figure out where polars make sense, where it might not make sense. If you want to connect with me on LinkedIn or Twitter, I'm there, happy to connect. Yeah, and again, have a great conference. Thanks for letting me present, and good luck with your future tabular data endeavors.